Greetings, you wonderful dwellers in AP Physics. Here we have an example of a 2D impulse/momentum. In the picture, you see a golf ball bouncing off of the wall, and you see that it comes into the wall at an angle of 30 degrees and the speed of 45 meters per second. It bounces off at the same speed, 45 meters per second, but in a different direction. Therefore, as soon as there is a directional change, there's acceleration. If there's acceleration, then there is a change in velocity. If there is a change in velocity, there is a change in momentum. And if there is a change in momentum, that means that an impulse had been applied to the object. And that is what we're after. They want us to find the magnitude and direction of the impulse applied by the ball to the floor. Here's the interesting thing. By the ball to the floor. Remember Newton's third law. Every action has an equal and opposite reaction. So if we figure out the impulse delivered to the ball by the floor and reverse the direction, that will be the impulse delivered by the ball to the floor. So that's what we're after. So let's start with the impulse to the ball, and then we will transpose it in the opposite direction to answer the question that is posed in this picture. Since this is a two-directional, so a 2D picture, I'm going to look at my Vx and Vy, and it's Vx initial and Vx final, Vy initial and Vy final, Vx initial, Vy initial. I'm going to resort to mathematical directional attribute of positive being to the right and positive being up. And I see that my direction of the incoming velocity, in other words, initial velocity, in the x direction is to the right, and it's going to be 45. This is my 30-degree angle right here. So if I'm looking at my velocity, then 30 degrees is over here as well. So x component is going to be 45 cos. No, actually sine, because it's across from it, so right? And then 45 cos will be the y direction. 45 sin of 30, and it's positive, so it's half of a 45, and then 45 cos of 30. But be careful, not only is it cos, but it's also negative, and that is due to the downward direction of my y component. So that's my factors that will create the golf ball's P initial. Now let's work with the final momentum of our golf ball. We have Vx final to be the same. It is still 45 sine of 30 degrees. It did not change direction horizontally. It's still going to the right, and it's still 45 sin. Vy final is 45 cos of 30, and it is upward now, right? So I'm going to keep it positive. Then what is my change in momentum y? If I am looking at my final momentum y minus initial momentum y, then I'm talking about 45 cosine as a positive minus 45 cosine that was negative to begin with. So obviously I'm going to have 90 cosine of 30 when I add them together, and then that is 45 roots of 3. Remember, change in momentum equals impulse. What we found, that is the impulse applied to the ball. It's 45 roots of 3 newtons times second in the upward direction. The answer to the question that was presented to us by this problem was negative 45 root of 3 newtons times seconds, or you can say it is 45 roots of 3 newtons times seconds. They asked for magnitude. Remember, here is your magnitude. And then since they asked for direction, I'm just going to say downward. There is your answer.